So this is the application we coded. It is being served through the ESP. When you click the switch button, it should turn on the LED, and vice versa. How's it going, guys? In this tutorial I'm gonna explain how to control simple LED with ESP32 board with your Wi-Fi on your smartphone without internet access. Why you should watch this tutorial? This tutorial doesn't need internet access at all. You will be using your phone as a remote controller without needing AC controller or using the cloud, and you will make your ESP32 as access point, as a router, so you're gonna use it completely offline. We're gonna start with building our web app that will be served through the ESP. We'll be using HTML, CSS and JavaScript in this web app, and then we're gonna code our ESP32 using C++. After that, we're gonna upload our code using Arduino IDE, so you need to download Arduino IDE, and then we connect the circuit. Our circuit is simple LED resistor, 220 ohms resistor, just to protect our ESP32 board. Of course, we're gonna need ESP32. At the end, we're gonna test this completely offline. We're gonna create our application using HTML and CSS and JavaScript. Here we have empty project. We're gonna start with HTML file and use the VS Code. Here is the file. We're gonna use the emit abbreviation to create this. Let's call it ESP32. We need to create our switch button. We're gonna use checkbox for this. Actually, checkbox is not the one we want. We're gonna style it. We opened our live server on this port using this extension, live server. We're gonna need this one. Here is the checkbox. The checkbox needs some styles to be like switch button. We're gonna style it appearance none, background, let's use this, and for the radius 5 pixels. Where it is, yeah, width, height 20. Here it is. Let's split our screen to be this way. I guess 50 is good, yeah. And then we're gonna style the pseudo before pseudo. It's gonna be absolute, and because it's absolute, we need to make the parent relative. Content should be empty, and we need to create the circle, white circle here. It will be width 16, height 16, background white, for the radius 50. Here's the white circle. We're gonna position it like 2 pixels from the left and the top. 2 pixels. It is centered here vertically, and then we need to control it when we click on it. So we're gonna use checked. If it's checked, we're gonna make the background royal blue. Here it is. Also, we want to move this circle to the right when we click it. So input, when it is checked, access the before sudo and make left, give it this value. It will be 100% of the width of the input minus the circle itself. The circle itself is 16 pixels plus the margin here, the left, so it will be 2 pixels. Here it is. We just need to wrap it here. Yeah, we need to add some animation. Transition is in out. I'm gonna make it specific to the left. Yeah, this is what we want. Right now we need to, let's focus on our code editor. We need to add some logic. We're gonna select the input, this one, document. Yeah, we can use the AI little bit, this. Yeah, input on change. We're gonna listen to changes to that checkbox. I'm gonna make arrow function and then pass the event. Let's log the event first. Target. Here when we click check and uncheck, we access the element. Then we can access the checked property in it. It will give us true if it checked, and vice versa. This way we can fetch our endpoint based on this. It will be lead status equal if e.target.checked true, then on, else it will be off. Let's use async await. Async response await fetch. Our endpoint will be lead. We're gonna create this endpoint, by the way, on the ESP using C++. So the endpoint will be /lead/on or off, and we have this as dynamic variable. It will be lead status. This way we can check the status. Okay, if it's okay, we can do something, and if it is not okay, do something also. Let's wrap this in try catch. No, where yeah, if it's okay, let's store the status response text. It will be empty string response text. It will be, by the way, we're gonna return the response of this endpoint of the ESP. It will be text, not JSON. So response text, we're gonna solve it this way, and we're gonna await. That's it. So we stored the response of the endpoint here in this variable, and if the response is not okay, we can just access it from here. Response text, it's here, I guess, status text. And here, if there is if we caught an error, it will be the message in the error, and we will fall back to this static message error connecting to ESP, and that's it. The last thing, we need to display this response text in the HTML. We're gonna add div, normal div. We can repeat this div at the end. The div text content, it will be equal response text. Let's check. When it is checked, then we call lead/on endpoint. When it is unchecked, it is lead off. This way we are fetching our endpoint and displaying the response. As you can see, it's not found because we are not serving the application from inside the ESP. So it's a normal error because we didn't connect that HTML. We didn't serve it yet from the ESP. Let's move to the second part, which is coding the ESP. In this part, we're gonna code our ESP32. We won't use Arduino IDE right now. We're gonna code inside the VS Codium. Here is the same project we had in the past, in the previous part, index.html file. We're gonna create ESP32. Let's create, yeah, here is the previous file, and we're gonna code this. The first thing, we need to include our Wi-Fi library. Include Wi-Fi library, and then include ESP async web server. We're gonna define our lead to pin 2, bin number 2. Define lead, it will be linked to bin 2, and we're gonna create the variable for the password and SSID of our access point that we're gonna create, because our ESP it will be act as access point, like router that we're gonna connect to by our smartphone. Const char asterisk here for not determining the length of the string. SSID, we can call it this way, okay, it doesn't matter. And the password, as you can see, we're gonna listen on port 80, and then we have two main functions, setup and loop. This is what we get when you open new sketch in the Arduino IDE. We're gonna use only the setup. The very first thing, by the way, we're gonna serve our HTML, that file, as a string. So we're gonna copy all this. We're gonna copy all this and store it here inside a variable. Const char, let's call it index HTML, like this. It will be here. So at the end we stored our HTML file inside this variable, okay. And then the very first thing we're gonna do with the GPIO2, we're gonna set the mode of it, because in IoT world we have two modes, sensors and actuators. The sensors, like the humidity sensor, it's input to the board, but in this case we need to send signal from the ESP to the real world, so it will be output. It's coming out from the board to the real world. So the bin mode will pass the lid, which is the bin 2, it's a value of bin 2. It will be output, okay. By the way, bin mode, it doesn't exist here in the file because it's accessible globally. So some functions we do access globally, it doesn't have to be in this file or imported here. It's supported globally. So after this we're gonna use this serial, this number, we're gonna use it while uploading the code. We're gonna choose it later in the Arduino IDE. We will have to add some we will have to print some lines, empty strings. Really, I don't know why, but we have to do it. It just works this way. Serial dot print and then serial like this, and we will pass our SSID and password to make the access point. Actually, we're gonna use this. It won't harm us to use some abbreviations from the AI, and the IP address, we will create this variable and we will get the IP from here, from the Wi-Fi dot soft access point IP, and then we will print these logs. We will create 3 endpoints right now. The very first one, it will be serving the HTML file that we have its content here. It will be server dot on this route. It will be get okay. Actually, we can go to complete this. The response will be HTML status code 200, and the content will be here, this one. This way we serve our HTML file through this endpoint. We will need to create another 2 endpoints. It will be server on this endpoint. If you remember, when we were coding the HTML file, we were using this here. Lead, we are calling it here from here, and then it will be get method, and here, by the way, digital write, here the response will be text. Okay, that's why we are using here, we are parsing it here as text. And the response LED is on. Here is the point. When we hit this endpoint LED on, we make the LED on by this function digital write. Digital write, actually it's a global function. We can access it and pass our LED pin number, which is 2, and high. That makes the LED on. We will create another endpoint to switch off the LED. It will be low to make it off. That's it. We just need to start our server. That's it. That's pretty much it. We just need to upload this code to our ESP and try it. Okay, we need to upload the code now to our board, but before that we need 2 libraries to be installed: ESP async web server and async TCP. We can download them as zip, and also we need the Arduino IDE. If you don't have it, you can download it from here. In my case, I'm using Linux, so I can download it, the latest version Linux 64 from here, but I'm gonna ignore this because I already downloaded it, and I downloaded these. So I have this after downloading the app image. I can change the mode of it. I already done this, but I'm gonna do it again. And then Arduino IDE. Yeah. Right now we need to select our board. Currently we didn't connect our board. We just connected with the USB type B to our PC. It is now connected. In my case, I have it on that path /div/tty USB 0. In your case, it may be different. I have to select it manually from here. ESP. If you are using Windows, you won't face all these. It will be easier. ESP32 Dev. Here it is. This is mine. Okay. And then we will include our libraries from here. Include a zip. Where it is in the download. No, not in the download. Okay, we can download them. Here's the first one and the second one. Async. All installed now. We can just open our .ino file that we have created in the previous section. It will be, yeah, here it is. We can close this and stick with this. Before everything, we have our SSID, the access point name, ESP32, and this is the password. We're gonna use it when connecting with our smartphone. Let's just check the speed and the port. Here is the port selected, and the speed, it should be this, as we have in the code here. And then we need to verify the code, compile it to check if there is an error before uploading. Yeah, as you can see, it is compiled successfully without any issue. We can upload it now. Some of the boards need to press the boot button for 3 seconds to upload the code, but this one it seems doesn't have to do this. So in case your code is not uploading and waiting at the sentence connecting, then you have to click that boot button on your port for 3 seconds to enter the mode, and that's it. Here it is finished successfully. We can remove our board from the PC and connect it again to check if the access point works or not. At this point we need to connect the pin 2 and the ground. So the blue wire goes for the pin number 2 and the gray wire to the ground. We will be needing this breadboard. We will connect this resistor. It's 220 ohms to the blue wire, just to protect our ESP board, and then connect the LED, one pin for the resistor and the other with the gray wire. The gray wire is the negative, should be connected with the negative pin of the LED. Just be careful about this. If it didn't work, you can reverse the LED. Right now we need to power up our board. We are using power bank 5 volt 1 amp. It's sufficient for our case. Right now we need to search for the access point. I changed the name of the access point to Wally. Here it is. We just need to connect and enter the password. I previously entered the password. Of course, the password that you added in the code. Yeah, we are connected now. We just need to know the IP of that access point. We will be needing the Fing app. You can download it from the Play Store and just scan or refresh your current network. You will find the router ID, router IP. Here it is. Just copy that IP and paste it in the browser to open our application. Here it is. So this is the application we coded. It is being served through the ESP. When you click the switch button, it should turn on the LED, and vice versa. Thank you guys for staying till the end. Of course, this project can be scaled up. For example, you can enhance it by adding relay, so you control at the end the light of your house. So you control the relay via the ESP, and then the relay control the light. Of course, you can add many crazy ideas to this project and scale it up. Thank you for staying till the end. See you in the next video.